We have a packed but amazing afternoon agenda. And kicking us off, I'm excited to announce we have Shon Urbas, who will be is the CTO and co-founder of Pandemum, where he spent years solving the integration challenges that slow developers down. And today he's sharing his talk, Can AI Build Your Next API Integration? This is behind the scenes lessons from experimenting with AI agents to accelerate integration development while keeping developers in control. So please welcome Shon to the stage.
Thank you. Can everyone hear me? Awesome. Hi, I'm Shon, CTO, co-founder of Pandium. On today's agenda, to sort of set the stage and explain what I'm about to show you, I need to tell you a little bit about what Pandium does. We'll go through our journey, and I forgot to update this slide. It's not a live demo. It's a slideshow of a demo, but that's okay. So yeah, me, hi. Before I get started, I know really gonna be really excited to hear about integrations and stuff. I know coming back from a full lunch, that's gonna be like something you're gonna wanna really be hearing about, but that's what Pandium does. We help our customers build and deploy integration ecosystems. A good example of this is one of our bigger customers. Their name is ShipBob. They do third-party logistics. They just help all their customers or businesses that ship on Shopify, BigCommerce, Wix. And Pandium helps power that marketplace where those merchants go to install their applications and run these integrations that are really critical to both ShipBob's business and their own. And so what we ask our engineering users to do is to build integrations on us. You're gonna write in code. We're not a low-code platform like some of you'll see out there, the N8s or the Zapiers or the MuleSofts. And so you still have the same fundamental issues when it comes to development, which are a lot of the time with developing integrations, you are working on boilerplate stuff. It's like all the same code over and over again, very similar patterns. It's not what your core requirements are. It's not what you're building for your own application. As you build these integrations, you realize they are actually full applications that require having authentication, making sure you're handling rate limiting, making sure you're thinking about, hey, when this one order comes in and it got duplicated, like what are you gonna do to fix that? And so there's a lot of challenges around writing integrations. It's basically the same challenges as writing normal applications. And so what we do is we make it easy for our engineer users to just focus on what's important, which is their business logic. And building this integration code is actually what we were asking them to do not until too long ago. At the bottom, you see our platform. It's the thing that handles like the front ends, the thing that people will use to install the integration. It's the stuff that's managing the secrets. So hey, I've connected my QuickBooks. I need to keep that connection active. That means managing OAuth 2 refresh tokens and stuff like that. We also have monitoring, and actually we have a secure enclave where we run the code. So you're running these integrations on our systems. The reason for that is we're managing the secrets for you. If they leave, then especially with OAuth 2 flows, it's very easy to break. And so coming into the last 2 years, having a platform was enough, but now you have this new revolution of AI and LLMs, and everything is like, what is Pandium doing for me? There's tons of runtime platforms. And so we really thought about what can we do to optimize the developer experience? And so really focusing in on the integration code and how it can help our users. And so just to start with our early days, so yeah, birth of ChatGPT, November 22, we were like, this thing is gonna write integrations for us. And so we just tried it. We were like, HubSpot to Twitter. It's the integration we use for all our, when we're interviewing new developers, we ask them to write an integration that can run in a command line. And so we asked the same thing. And it's our benchmark to see how these models have evolved over time. It did a terrible, terrible job back then. It was just a lot of nonsense, no error handling, no rate limiting, mismatching objects, hallucinating entire functions. We all remember. So we thought, though, that there's something here. There's some nugget. And so waiting a few months later, we tried to partner. We didn't believe we had the expertise in-house to like actually tackle this. And so we attempted to work with consulting firms. And so they promised they'll take what we had, our little toy, wasn't really working, make it production ready. Didn't work out as we hoped, as sometimes happens. I'm not saying don't hire consultants. It's just something to think about when a new technology drops. Who is really an expert? And so that's actually a really interesting point, imposter syndrome, but that's a whole separate discussion. So yeah, as a part of the exercise though, so we went from this really naive, like generate the entire integration. We were like, all right, these guys don't know what they're really doing, but we did pay for them. What can they give us? And so that was part of it, but it was also like, how much of the integration actually needs to be coded in a way that's like not really just the same code over and over again. And so thinking about that led us to the discovery of like, hey, what if we just had to do the mapping? Literally just the mapping of JSON. And we did everything else deterministically. And with that, we got to this JSON key path mapping problem, I like to call it. And so the idea is you have a source API and you have a target API. You can see that customer info has a full name and a contact in the source API. And then in the target API, we're trying to make this shape into name and email address. So you have to do some deep path to get that email off the contact object. And so at the bottom here, you'll see what we actually ended up generating. So we would take API documentation, get the types out of them, and then just walk the path of the type to generate these strings right here. $ means root, then it's just dot, that means every object access. We also support square braces. This is a standard JSON path. And the idea was to use the model to just say, hey, well, we have a string here, just make it a different string here. Like, what's the most logical set of strings given these two sets of strings? That also failed terribly. Again, that goes back to the consultant and not really having a good like testing plan. We went through many iterations and like, I think it got us like 70 or 60%. And we were just like, what it generated wasn't useful. And so we went back to the drawing board, we thought about this, and frankly, a lot of the code that we had to like think about to give to this model, we could do at scale if we just like worked on it and like focused and used our thing. So for example, API client generation. Shopify has an API. Shopify is not a great example because they have amazing SDK. But there are companies out there who have great docs but have no SDK. You're lucky if you can get a Swagger document out of them. And so we take those Swagger docs or generate using an LLM to get to the Swagger doc and use that to build an API client in TypeScript. That gives us type safety, that gives us all the different functions. So when you're writing this in IDE, it just becomes a lot nicer. One of the things that we also handle, and I don't think is handled automatically really with OpenAPI, is rate limiting. Rate limiting and making these things asynchronous. So, which is kind of catchy, which is kind of a mess when you're thinking about it asynchronously, but like you wanna make sure that you're not making new requests if you're out of your quota, for example, and just handling that for the developer so they don't have to think about it. They just wanna like iterate over a collection. The project scaffolding, all these integrations look the same, they all are just basic CLIs. We could provide that to start. And then documentation, automatic documentation generation, readmes, spec sheets, all this stuff that's just like, takes time to build and you still need to go in and look at, but like we could automate the vast majority of this and give people more value. At least that was the idea. This is before we did any LLM though. Like we weren't adding AI here. We were able to just, in all these cases, we're using code gen, we're just taking an input and doing something to it, and then it comes out as a bigger output. Maybe it's a text replace, maybe it's a In the case of the Open API, we were using this thing called type open safe generator. I forget the name of the library. I'll handle it later. I came here. This was last year. I was here at the opening conference. It was a really great time. This is so much nicer. It's bigger now and like even nicer. I submitted a talk. I was really jaded. I was really jaded after this JSON path debacle. And so luckily it was rejected. AI integration hype versus the reality, why it doesn't work. But what I did learn and what gave me new hope and like, hey, maybe we should start doing this again, put some more insights into this, more resources, is people's enthusiasm. Y'all are amazing people, and we're doing really cool stuff, and the people that presented last year were really great presenters, and they gave really good, they were just showing toys in a lot of the cases. It was still really early days, but what they were doing was showing a lot of clever patterns. Some of the stuff that eventually we would call agentic, I was first discovering at this conference last year. It wasn't coined yet, I don't think, at least not by the wider world. And so some of what it did was it reinforced my insight into like, coming from that previous failure was like, well, the vast majority of this is deterministic, but maybe, hey, things have moved on. I could give the mapping another shot, right? And so we tried it. So what changed at the end that allowed us to do this? So we have much larger context now. You can drop in 100,000 characters. Some have 1 million, I think. I think Gemini's up to 1 million. 2 million now. Anyway, it's too fast. You can't keep up. Context engineering, I fucking hate this term for the record. Sorry for cursing. Only because it was coined 3 weeks ago, and like we've been doing it the whole time. But it is an interesting thought, and I thought about it. Like, how is context engineering different from prompt engineering? And it's actually, I guess, it's this idea of like making sure you only put in the info that's needed in the prompt. Once these prompts got really big, it was easy to just dump everything in, and that gives you bad code. So I guess there is a difference, but like I don't know if that's what anyone was thinking when they were coining that term. And then you just get more reliable code. Like you don't have to worry about telling it how to format. You could just say, hey, it's Python or TypeScript. In the past, that would give you bad results. The next thing is like, and this I think was the key thing, is like we're still doing a very small part of this integration. And I'll show some code in a little bit. We're just trying to do the mapping code, the code that says, hey, take this one object from one API and turn it into another and send it along. It's a little bit bigger than just doing the JSON path, so we gave more faith to the thing. And it's working out pretty okay. The way you get there, and this was something that was said earlier, lots of constraints. So we're using Claude as the base model here, and one of the things we tuned on that was the temperature. Temperature is this new thing. Is it new? I don't know. But like this idea of like, if you give the same prompt to the model, it should give you something that is almost the same as the first time you gave the prompt. And so turning that to 0, for example, very uncreative. But that was what we needed because we had our prompt is really focused. We know how to build these integrations. We can give it a copy of what one looks like. We wanted to just do a copy. We wanted to be very dumb, but smart. Robust testing and validation. So making sure you have automated testing. You're benchmarking. We have a benchmark now where we have 8 different flows from 4 different systems that we iterate on and see, did the changes to our model, did the changes to the prompt materially improve the output? And you can have some automated stuff, but still, coding is an art, and you got to look at it sometimes and just making a qualitative judgment. And then it's also important to make sure you deal with failure, and I'll get to that in a little bit. So this is the pipeline. I don't want to leave too far from here. But on the upper right, you'll see the input. I'll show you an example of that in 1 second. We do analysis. We're like, hey, okay, so the input is really simple. Let me just jump. So the input is actually really simple. It's just this 4 lines down here. It's like, what's connector A? What's resource A? What's connector B? What's resource B? There is no prompt that a user is typing in. They're using a form. And or if they're using a CLI, they're just doing it with command options, but it's not a prompt. And the reason for that is because we're actually going to generate the prompt for them, right? Our prompts tend to be around 30,000 lines right now. And a lot of that has to do with code and message definitions. We're not going to have our user do that. So we do the analysis. We figure out, hey, what methods are actually required for this model to be aware of? These clients are 100,000 lines of code. It's a TypeScript library with thousands of types. And you don't want to give that all to the model. It just doesn't know what to do with it. But if you know, hey, I am moving an order from ShipBob and I'm turning that into a sales record in ActiveCampaign, then maybe all I need to do is have the model like go and get the sales order, anything that has an order in the word, actually, order in the type. So jumping a little bit, this is an example of pulling a product, for example. So it's really hard to see, but this is the name of a method called list products that exists on ShipBob's client. And these are all the different objects and types that could be associated with that list product. We had to go all the way down the tree of types because a ShipBob order, this response object right here, this request, is actually pretty complex. It has an array, it has the actual order objects, it has the requests, it has the lines. Anyway, we wanted to give the API, the LLM model, exactly what it could use to build these things. Don't try to hallucinate anything. Don't try to but also not giving it everything. If we're not talking about products, there's no list orders in this response that gets added to the prompt. And then here's an actual example of generated code. So this is 96 lines of code. I, on the side, zoomed in. So we're just starting with the imports. And here, this is an example of a MindBody to ActiveCampaign integration. We import those clients that we generated pre-hand. You can see they're just normal TypeScript packages. This is the mapping function. So this takes a sale in ActiveCampaign and turns it into an order in MindBody, or vice versa, I forget. But what you see here is just essentially a mapping function. This is taking a bunch of parameters and parsing it and turning it into an object that works with the API that we're about to send it to. And then this is the actual running code that does the physical flow. And so here, it's a function that accepts the clients. There's something, so Pandium, we have the ability for our engineering users to specify configuration variables that they're expecting users who are installing the integration to set. The LLM generated those by itself. Like it figured out, hey, ActiveCampaign needs a connection ID and a custom ID, and those need to be given outside of this process. They're like one-time things. It's gonna ask for them. And if those configs don't exist, it doesn't even try to run the integration. And getting past it, here is the actual loop. And I'm sorry this is not big, but you'll note like we're getting all the sales from MindBody, we're awaiting and iterating over them, and then we're just calling that sale to order function I showed you a little bit earlier. And then that gives us the actual order, and we ship it to ActiveCampaign. This is great. This is a toy, though. This is not something I would deploy into prod. One of the big issues here is this create order. What if there's a duplicate? Or what if the order doesn't actually conform to the correct shape? Like this integration just fails. And that's just an example of like, it gives you a really great starting point, and it's something that a developer can then go and iterate on, but it's not the end all be all of everything. In that example, so I just showed you, this is the code that was generated by the AI. This is surrounded by another 200,000 lines of code. So when when a user goes and fills out this form and generates an integration repository, they're getting 200,000 lines of code. Most of it is the clients, and it's an NPM repo, but it still counts. And only 96 of it is truly the LLM. And this just goes back, I just want to say, like 2 years ago, we didn't even have the clients. So like we were trying to get the LLM to do all of that. Ultimately, we ended up saying, all right, it could just do this 96 lines. And it could do it okay. you still need to help it a little. So what are some of the technical lessons? Scope limitation. It's really important to say, hey, you're only going to do this one thing. You're only going to do it really well. I failed to mention this earlier, but in this pipeline, we always use a new context. I saw some of you guys cringe about my content prompting and everything. For us, the way we track our token usage is we have an API key, and then I put a $100 limit on it. And when we hit that $100, I'm like, let me think about it. And so we haven't had to actually have that problem yet. So I'll get to that, hopefully when this blows up, I'll have to think about token usage. Key lessons learned. So scope limitation, hybrid approach. Combined AI with deterministic systems. Going back to that point about context, if you're making the one object and it succeeds, you can save that into a database, and then the next time someone asks for that prompt, we can return it. We don't have to send everything. So you can make this actually 100% deterministic. Validation is so critical. You have to test. And the other idea is, so I keep on jumping around, I'm sorry. But in this pipeline, there's a key step here, which is failure is less than 3. So we do all this work, we generate the scaffolding, we generate these API clients, we go to the LLM and we're like, hey, we need you to generate this mapping. And we take that output and we immediately try to compile it. If that fails, we'll take what was spit out by the compile fail, the npm install or whatever, and put that back into the LLM with the rest of the context and say, try again. And actually 85% of the time when it fails about 90%, not 90%, 10%. And when it fails, of that 10%, we're able to recover 85%, if that makes sense. So the idea is just have graceful degradation. So if the LLM fails, you still have the other 200,000 lines of code. Just put a comment in that says, sorry, we couldn't do your mapping. Keep on going though, right? And the other key part is, there's no prompt, you're not chatting with this. We expect you, once you generated this, to then use your local AI, whatever tool you want, to keep on iterating on the code. Failure, yeah. The future of AI integration development. So at Pandium specifically, one of the things we want to work on, I was talking to you, just saw in that code issue, was upserts. That's not on here, but the idea of hey, you should check if you're trying to create an object. And just ask it to do that. It'll do a pretty good job, these later model APIs, LLMs. Multiple objects as single object flows. That's actually a pretty common use case. You have to build a record from multiple sources before you can put it into the source API, to the receiving API. Making it work with web events, so webhooks. Right now, these integrations are only cron-based for the LLM, but there are some APIs where, there are some integrations where you need it to respond to a webhook, and then offering our developer users CLI access to this so that they can do some interesting things like fork and build. Hey, I have this really complex Zero integration between ShipBob and Zero. Wouldn't it be cool, if I could just generate a ShipBob to QuickBooks integration now, and not just a simple flow. We've done all the complex work. We've learned what ShipBob does. It shouldn't be that hard. We have to do some testing here, and again, benchmarking is really important to me. And so, how to think about testing this? How do you it's a lot of code. API assisted API client generation. It's still kind of manual, and then automated performance tuning, where we're looking at the rate limiting and token usage and using that to tune how often we will run a piece of code or not. And these are just some of my thoughts. AI will augment, not replace developers. I think senior developers are actually in a great place right now. I am concerned a little bit about junior developers. Just to note, I have an 8-year-old who's going to college in September, and he's studying computer science, actually game design, but that's okay. And LLMs are going to be a huge part of his going to college. I don't know what he's going to do, but it's really interesting. That said, I know developers now, pre-LLM, don't know what CPU does, doesn't know what RAM is. There are people who can program that don't need to know how everything works. Keep your tools domain specific. what won't happen? We won't automate away everyone's jobs. AI is definitely not replacing expertise, and I don't think there'll be AGI. I think that's what I mean when I say one size fits all AI, because that's the implication of that. I don't know if that's true or not, but if the AGI overloads watch this in the future, I'm sorry. Don't try to build the entire system from scratch was a big learning, but definitely try to accelerate and keep it what we've always been doing for the last 8 years is keep the developer focused on the business logic. Thank you. Sorry about that.
Yeah, I wish we had more time for
Yeah.
Q&A. We got to keep moving. But thank you so much. Awesome lessons learned and insights, Shon.